Everybody, we're in our new classroom, moved up. I am very happy to introduce to you Mario, who's going to talk to us about an IDE for the NES console.
Thank you. So as Perry was saying, my project revolved around the NES and making it easier to develop games for it through an IDE. So who here knows who this guy is? Right? He's become iconic. It's kind of cool that you can be able to recognize that character with just a couple pixels. And even after 35 years, he's going to continue to be there. And I think that's really cool. And just kind of lends credence to the idea that pixel art is an important part of our cultural heritage. I've actually never even played Kirby or the game on the right, Undertale, but I still know who those characters are and what games they come from. And that kind of speaks for itself. Like, you have an entire culture surrounding this pixel art industry and I guess just way of expressing yourself in video games. And I use the term pixel art loosely. There's two different subdivisions it can fall into. Pixel mapped art, which is what my project focuses on, and then 8-bit art, which has more concrete definition that I'll go into. The problem that I identified was that maintaining and expanding 8-bit art, or true 8-bit art anyway, is hard due to technical limitations. When you think of old consoles, all of them were developed using assembly language, which is not easy. It's never being taught in colleges, and even when it was a big part of the industry in the 70s for the NES kind of era, it was never taught in colleges. You had to pick it up by yourself or get recruited by a company that would develop NES games, and that's how you would learn how to program them. So it never had a big following in terms of knowing how to program them. So I thought, why not try to make it a little bit easier and kind of keep that momentum going for creating 8-bit art? So time to actually, identify what 8-bit art really means. If we're being true to the definition of 8-bit, it means you got 256 colors you could possibly choose from at one time. The NES, however, does not have that luxury. You've got 8 bits, and within those 8 bits, 2 of them are dedicated to determining where that pixel is going to be, a couple more bits determining what kind of colors you could possibly choose from, and then a couple more bits to determine what color it's actually going to be. So when all said and done, you can only have a maximum of 25 colors displayed on the screen at one time. So that's kind of a big drop off from the original 256 that true 8-bit is versus what the NES actually deals with, which is 25. So I got a graph here showing how video games actually grew over time. There was a huge surge in the 70s that happened because of the NES and made 8-bit consoles very, very popular. And because of that, the surge of 8-bit art continued to grow and became very recognizable with some Mario sprites and Kirby sprites. So I figured if I'm going to try and preserve the 8-bit art, I think it'd be easiest to continue the momentum and the foundation that those consoles laid out and continue to expand the art through video games and making the video games. So the reason why I chose the NES was because its CPU is shared with the Commodore 64 and the Apple II. Those two computers were huge flagship computers when they first came out, and because of that, they got a really good documentation for the assembly language that they support. So I think that'd be a good starting point. Of course, I'm also a little biased. I love the Legend of Zelda and Mario. So I figured with those two reasons, why not go with the NES? So the current options available for actually developing NES games was in IDE, which overlays over Eclipse, and is actually not useful at all. There's a huge learning curve, and there's no tile or palette editor. So you're stuck with creating a whole bunch of sprites and tiles and palettes in hexadecimal code, which is not easy and it's not fun. It's just not useful. NodeNES is actually a website that I obtained a lot of inspiration from for how to actually lay out my IDE, and I noticed that they had one problem that kind of made NES development pretty difficult. You only were allowed to have 4 colors for an entire 256 tile sheet, for the sprites, and then another 256 tiles, which were also the same color again for the background tiles. So you have all this entire page of 4-color art. It's just not easy to see, and it's not a good representation of what you're actually going to be developing or showing on the screen. And then NES Maker actually had a Kickstarter recently that allows for non-programmers to create NES games, which is really interesting. It's a real modern, interesting concept, but the problem with it is that you get charged for making the games and to even own the IDE. So my solution was to make a free IDE that was able to be used on the browser, so it's platform independent, and it has a whole bunch of tools to make developing tiles and sprites easier. I've got a palette editor on the top left right there, and what that allows me to do is select which tiles have a certain palette. So you can assign it a palette 1 through 4, and then you're able to view that single tile with the colors you intend to give it when you actually are running the game. And then you have the entire NES possible colors. So 64 there, but only 55 of which are unique, which was interesting. I'm not exactly sure why that happened, but I think there were some technical limitations for the hardware at the time. And then you have a co-editor at the top right, and then you're able to switch between sprite and background tiles that you can edit down there. And the components I'm going to be using was a web browser user interface. So that allowed me to develop anywhere I wanted to that had a Linux subsystem. So it doesn't matter if you're working on Firefox or Google Chrome, the experience is always going to be the same. And then I used Node.js for a local server. I was brought to the attention of Node.js and that I would actually want to be using it through Michael. And then through web development, a course that was taught in the J term with Mark Mahoney, he kind of helped reaffirm that I made the right choice with Node.js. Developing a local server was super easy, and it had a lot of tools available to make developing my IDE really easy. And then I used NetSasm, which is an NES assembler, which will create a binary file. And with that binary file, it's exactly what you would load into a cartridge and then drop that into an NES. So it's being emulated through FCEUX, which will be run on the desktop to actually show the game that you created. So some examples of what is actually being done in the background on the local server. You've got the colors being set on the top left image, and then you'll get some hexadecimal code. And then you can create some tiles in the middle, and then again, you'll get some hexadecimal code. And then you can create some assembly language code for the NES. And then through the assembler, it'll take all the things that I did in the background that you had no idea was happening and drop it into a .NES file. And that's what you'll drop into the emulator, and it'll show what you've done. So the way that my project worked was that it uses a project-based system. You can kind of imagine it sort of like Visual Studio or Eclipse, where you pick the folder you want to open, and then I know Visual Studio has a solution file that'll kind of map out and tell the IDE where all the files are located, what kind of settings you had at the time. And that's kind of what I had going on with my project. I wanted to open up a folder that was created by the local server, and then that would load in the rest of the files I needed to use. So if you click the new project, it'll load in a whole set of files on your hard drive. And then with those files, you have an immediately runnable game. Just some default code to get you running, so that way you can see how the NES emulation or NES development works. And then you can open the project so you can continue development. I'll be showing you a program I made that took several weeks to develop. So having that option there really helped me to pick up development over several days. And then you have the ability to save a project, which will take the code you wrote on the user interface side, and then convert it over onto the desktop in a hexadecimal format that you would never actually want to work with. and then running the project, it's going to call all the files through operating system codes to develop what you see on the far right. So whatever game you made will be shown on that emulator right there. And to show you that my project works and what I developed, I'm first going to have to start my local server. And then I'm going to have to navigate to it on the browser. So this is what it looks like when you first open it. Not much to look at, but if you start a new project, I'm just going to call it demo for today. You'll see that it'll load all the default code that I was talking about, and then you'll be able to run the project as soon as it's loaded. So what actually happens when you run the project, well, it's not good. So what would happen though is if you select the palette here, so on the top left corner you've got what palette you want to work with. So changing the palette to palette 2 will change the colors you're working with at the time. So if you were to change the color here, it would show up on there and it would make all the changes to the available colors on the existing tiles you have. And then to show you that that save would actually occur on the hard drive is that you would save the project, then you could reload the page, and then you would open the demo. And then that same change is still made. And then to show you a project that I was working on, I've got all the Mario tiles that I was able to rip off of a ROM, and then those are stored on my hard drive. And then I'm able to edit the palettes here. So say you want to give Mario a brown hat, there it is. And then to actually show it running, you'd be able to see it right there. So let me zoom in a little bit. And then you'd be able to control the movement of Mario's top left face sprite through some keyboard mappings I was able to emulate on the emulator. So I'm moving it around the screen, and then it uses a lot of assembly logic to actually get the sprite moving, a lot of assembly logic to display the sprites, and then again to display the background tiles. And some of the lessons I learned were more kind of lessons that everyone can kind of take away, was reading the manual. I know it's been talked about a lot today, where you're just not going to be able to get away with it, especially when you're tackling an entire ecosystem you've never learned before. The NES is a really old system with a lot of dated terminology that just flew right over my head. And there's no real way to understand the ecosystem unless you just sit down and really try to take it all in. And there's really no shortcut for that. I tried doing that and it burned me a lot of times. And then another thing I learned about was acknowledging how to write good web browser code. JavaScript does have some strengths and weaknesses that you have to acknowledge when you're actually coding web apps. So I was able to figure out what I did wrong the first time I wrote the app, and then offload a lot of the computationally expensive work onto the Node.js server. And that allowed me to increase the performance on the client side and actually have even more power that I didn't even know was possible through the Node.js libraries that I was able to work with. And then some personal accomplishments I was able to do was I was finally able to, I guess, tackle my goal of learning how to program for the NES. I can't really explain why I wanted to code for the NES. I actually never even owned the NES or played the original Super Mario or Zelda games. But I thought it'd be a cool thing to tackle, especially since it was so old, and apparently computer organization didn't scare me enough, so I figured, why not try assembly in NES? And it was actually kind of fun. And then I was able to create a free NES IDE that covers the pitfalls to the other programs. the biggest pitfalls were being able to pick up development right where you left off through the project folder scheme, and then being able to have, I guess, an integrated form of being able to test your code on the fly. You create your code, you're able to assemble it, and then run it on an emulator with a single click of a button, which I thought was kind of cool and reminded me of Visual Studio, where you just pick or push the green button and it magically happens, your code's running. I really like that part of my program. And then how I grew personally. This project was something else. I didn't know how I was actually able to come to the point I was able to reach today, because there were a lot of times where I just felt completely lost and helpless. There were so many times where I just felt like no matter how many times I was reading the documentation, it still wasn't making sense. And unfortunately, because the NES community has a lot of resources, people have a lot of opinions on how to use those resources or what they recommend. So the assembler I chose was split along with like 10 other popular choices. So because of that, there wasn't a clear consensus or a lot of examples for one single assembler. So you kind of pick information from each different assembler and how that assembler decides to interpret NES code from all these different resources and example code sets that aren't really, if you were to look at them, they'd all look completely different, unfortunately. So being able to look at the code from one assembler, you have no idea what's actually going on, and trying to convert it into something that that NES system actually interprets well was a huge problem. But I was able to overcome it, and I think that made me a better person or a better programmer. And then I also strengthened my ability to dissect a problem into smaller parts. I've always heard that it's a strong characteristic to have, especially for employers who are looking to have good programmers. You always hear your professors say, well, just dissect the problem. It'll make more sense if you break it into smaller parts. But when you work with something that's completely foreign to you, and you have to take into account an entire ecosystem that is completely new to you, both software and hardware side, there's just so many things you have to take into account that I didn't even realize when I was writing my first project proposal. There's a whole lot of revisions I had to, that I hadn't foreseen coming, which slowed down development, but in the end I was able to piece everything together, make connections that I didn't even think about when I first started programming. But the more work I put into the project, the more clear it became on where I needed to fill in the missing gaps of information. And once I found those missing gaps of information, development became a lot more easy. And I thought that was a cool process to actually go through and be thrown right into the deep end and then come out a better programmer. Thank you for watching my presentation. Yes, Michael.
So occasionally after Comp Board or other classes where they take assembly, students will sometimes say they might never want to use assembly again. But doing this project in assembly, did it give you a new perspective on coding in assembly, or would you want to in the future again?
Definitely not for employment opportunities. I don't think I could see myself being happy coding assembly. It was a hell of a time doing it for a grade, but I don't know. I mean, it's a niche market, so maybe there's some employment opportunities there. But I do think that going through Comp.org made learning assembly for the NES a lot more easy. The ecosystem was actually a lot easier than the assembly we learned, the ARMv8, because there's a lot fewer registers to work with, actually only 3, one of which was dedicated to logic. The other 2 were incapable of doing arithmetic. So it was a lot easier to read, because if you see a mathematical assembly opcode, you know for sure that it's only going to work on one register, so you know exactly where to load your data into. So in that sense, it was easier, but it was just a whole new experience for me that it was a really hard thing to work on. Yeah.
So if I understood it correctly, the server, you'd have to run that on your machine and it saves to the file system?
Yes.
Is there any reason that you consider instead of storing the the output of a file? Could you store that in a database and then actually make this, say, a public?
So I didn't even think, yeah, so the question was, is there some avenues I could explore with setting up a database instead of having all the files stored locally? That was actually something I didn't think about. I thought it was an okay option to store the files locally because all the operating system commands that I have to run through the Node.js would be run locally, so I would know the file system exactly. If I wanted to do a database setup, I think I would need to have a huge overhaul with some of the underlying Node.js code on the server that would I would have to have a whole user system, I think, to actually assign code to one user and then be able to run that. And then I would have to have, I guess, a whole new system for deploying my code to the user's desktop because I imagine if you had a database set up like that, you want to share it to people with different operating systems. And that was one downside I found with my project was it worked really well for Linux, but once I was working with some of the commands for the OS, you would have to kind of port that over for Windows and then figure out what dependencies were needed. So I think that'd be a cool avenue to explore, but it would definitely require a lot more work on my end to actually make happen.
More questions? Very good.